talk about solving some of these cubed root functions. Suppose I want to solve the cubed root of 5x minus 1 is equal to 4. Well, to get rid of a cubed root, you need to cube both sides. So when I cube both sides, since cubed root and cubed are inverses, that is going to go away, and I'm going to be left with 5x minus 1. So what is 4 cubed? Well, 4 times 4 is 16, times 4 is 64. Now I need to isolate my x, so I'm going to add 1 to both sides. So 5x is 65. Divide both sides through by 5. So I'm going to get x is 13. You're not going to get extraneous solutions with the odd powers, the odd roots. So I can check it, but I don't need to worry about extraneous solutions. What if I have a square here? So what you're going to want to do is isolate your radical again. I'm going to divide both sides through by 3. That pen keeps disappearing on me. So this is going to be x plus 1. And I'm going to write this as a cubed root of x plus 1, the whole thing squared. And I'm about to show you why. When I do that, now when I take the square root of both sides, I'm going to be left with the cubed root of x plus 1, and the square root of 4 is 2. Now I took the square root, so it could be plus 2 or minus 2. So I need that plus or minus. So I'm going to have two equations. The cubed root of x plus 1 is equal to 2, and the cubed root of x plus 1 is equal to negative 2. To solve this equation, to get rid of the cubed root, I'm going to cube both sides. So x plus 1 is 8, or x is 7. For this one, I'm going to cube both sides. So x plus 1 is negative 8. So when I subtract 1 from both sides, x is negative 9. Now you do want to check these. Go back to your original equation. Let me switch pen colors. So when x is 7, 3 times 7 plus 1 to the 2/3. Let's see what this equals. This is 3 times 8 to the 2/3. Now you're going to want to do the 1/3 first. So 8 to the 1/3 is 2. So this is 3 times 2 squared, which is 3 times 4, which is 12. Now, what happens when we put in the negative? 3 times negative 9 plus 1 to the 2/3. Well, this is what? 3 times negative 8 to the 2/3. Again, you want to do that cubed root first. Negative 8 to the 1/3. I'll write it out here, squared. So this is 3 times negative 2 squared. Negative 2 squared is 4. So this is 12. So we have two answers. When you have something like 3 times the cubed root of x plus 1 to the 5th plus 1, we only have odd powers and roots, so let's start by eliminating the 1 from this side. So I'm going to have 3 times the cubed root of x plus 1 to the 5th is equal to 98. Excuse me, 96. So I divide both sides through by 3. So the cubed root of x plus 1 to the 5th is 32. So there are a couple of things you can do here. I'm going to actually switch the order. I'm going to write this as the cubed root of x plus 1, whole thing to the 5th. Why? Because I know 32 is 2 to the 5th. So let me switch pen colors to kind of show you what I'm doing. In order to get rid of the 5, I'm going to raise everything to the 1/5 power. So those cancel, and I'm left with the cubed root of x plus 1 is equal to 2. To get rid of the cube root, I'm going to cube both sides. So I have x plus 1 is equal to 8. Subtract 1. X is equal to 7. Now, you could have done quite a bit more and multiplied out and found some pretty large roots. I prefer not to do that. I prefer to take the root and try to keep things as small and manageable as possible, especially if you're not going to have a calculator on the test.